What is a derivative? A derivative is an expression representing the rate of change of a function with respect to an independent variable. A derivative written as a function is written as the limit as h approaches 0 of f of x plus h minus f of x divided by h. You can use this function to figure out the derivative of any function. Once you figured out the derivative of a function, then you also have the slope, the instantaneous velocity, and the instantaneous speed. Besides the derivative function, you can also use derivative rules to figure out a derivative. One of the rules is the constant rules. The constant rule states that if f of x is equal to c, then the derivative of f of x is 0. It also states that if f of x is equal to x, then the derivative of f of x is equal to 1. So for an example, if f of x is equal to pi, then the derivative is equal to 0, because pi is just a constant. Another rule is the constant multiple rule. This rule states that if f of x is equal to c times g of x, then the derivative of it is equal to c times the derivative of g of x. So for an example, if f of x is equal to 3x, then the derivative is equal to 3 times the derivative of x, which in the previous slide we figured out that the derivative of x is just 1. So we would take 3 times 1, which is equal to 3. So the derivative of this function is 3. Another rule is the sum and the difference rule. This rule states that if f of x is equal to g of x plus h of x, then the derivative is equal to the derivative of g of x plus the derivative of h of x. The difference is works the same way. So if f of x is equal to g of x minus h of x, then you take the derivative of g of x minus the derivative of h of x. So for an example, if f of x is equal to x plus 4, then you take the derivative of x, and you take the derivative of 4, and you add them together. The derivative of x is 1, and the derivative of 4 is 0. So the derivative of this function is 1 plus 0, which is 1. Another rule is the power rule. The power rule states that if f of x is equal to x to the power of h, then the derivative is equal to h times x to the power of h minus 1. So what we did was we took the power and we moved it to the front and multiplied it by x to the power of minus 1. So for example, if f of x is equal to x to the third power, then the derivative of f of x is equal to 3 times x to the 3 minus 1. So the derivative is 3x squared. Another rule is the product rule. The product rule states that if f of x is equal to g of x times h of x, then the derivative is the derivative of g of x times h of x plus g of x times the derivative of h of x. A good way to remember this is just the derivative of the first one times the second one plus the derivative of the second one times the first one. So, for example, if f of x is equal to x times sine x, then you take the derivative of the first one times the second one plus the first one times the derivative of the second one. So the derivative of x times sine of x plus x times the derivative of sine of x. The derivative of x is 1, then you bring down the sine of x plus you bring down the x times the derivative of sine of x, which is cosine x. So the derivative of this function is x times sine of x plus cosine of x. Another rule is the quotient rule. The quotient rule states that f of x is equal to g of x over h of x, then the derivative is equal to the derivative of g of x times h of x minus g of x times the derivative of h of x, all divided by h of x squared. A good way to remember this is the derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. So for an example, if f of x is equal to x divided by sine of x, then you'll take the derivative of the top, which is the derivative of x, times the bottom, which is sine x, minus the top, which is x, times the derivative of the bottom, which is the derivative of sine x, all divided by sine x squared. The derivative of x is 1, times you bring down the sine x, minus you bring down the x, times the derivative of sine, which is cosine x, and then it's still all over sine x squared. So the derivative of this function is negative x sine of x plus cosine of x, all divided by sine of x squared. The final rule is the chain rule. The chain rule is used when the x in the function is more than just x. So if x is squared, then we know to use the chain rule. The chain rule states that the derivative of f of g of x is equal to the derivative of x with just g of x times the derivative of g of x. So, for an example, if f of x is equal to sine x squared, then the derivative of f of x is equal to the derivative of sine, and then g of x, which is x squared, times the derivative of g of x, which is the derivative of x squared. A good way to remember this is you take the derivative of the outside and bring it down, and then you take the inside and just bring it down and put it inside of the derivative of the outside. And then you bring the inside down again and take the derivative of it. So the derivative of sine is cosine, and then we just brought down the middle, which is x squared, and then we took the derivative of it on the outside, which is 2x, using the power rule. With derivatives, we also use trig functions. So it's good to know the derivatives of these trig functions, which the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant squared, the derivative of cosecant is negative cosecant times cotangent, the derivative of secant is secant times tangent, and the derivative of cotangent is negative cosecant squared. And it's just good to memorize these because you'll use them when you're finding derivatives. Another thing to memorize is the derivatives of exponential functions, which states that the derivative of e of x is just e of x, and then the derivative of natural log x is just 1 over x. And that concludes this presentation.